Hi, I'm Dr. Michael Scranny, and welcome to the DCU School of Computing's PhD research series, where each week we take one PhD student and put a spotlight on their work. We ask them 3 questions: a bit about themselves, a bit about their research, and then finally why their research is important. And this week we have Camille Ballas, who's going to tell us about optimizing neural networks.
So hi, my name is Camille Ballas. I am a third year PhD candidate in the School of Computing here in DCU, and today I'm going to talk to you about my research. So first, a bit of background about me. As you may have noticed, I'm from France, so I did my master's degree in computer science in Paris at EFRE, which is an engineering school. And then during the last year of my study, I moved to Cork to do a double degree with UCC in data science, and that's where I got in touch with the Insight Center for Data Analytics, which is the lab I'm working with here in DCU. So during my master thesis, I started working with deep learning models, and I was studying how hyperparameters were influencing the training of deep neural networks. And when I finished my master's thesis, I moved here in Dublin to do a 1-year internship with DCU, which followed by a PhD, and I'm now in my 3rd year. So my work has to do with deep neural network compression. Deep learning is used everywhere, from natural language processing to help you refine your query on Google, to more computer vision applications such as image recognition, or even up to the filters you will be using on Instagram or Snapchat, and it can go up to autonomous driving as well. But to reach those diversity of application, we need a diversity of model architecture, and over the year, the model that we use to perform those tasks have been gotten bigger and bigger, which means they are really, really long to train. And by training, I mean to be able to solve the task. We need to teach the network how to solve it, and that's what I'm saying by training. But this process takes a long time because of all those parameters the computer needs to learn how to tune them. And when we put them after into production environment, they are also big, and they are very challenging to be running on embedded devices such as a smartphone. So my work basically is looking at reduce the size of those models. But lots of research has already been done in looking at reducing the size from a production perspective, but I'm trying to target the problem from a training perspective. So I'm trying to reduce the size of the model along as they are learning how to solve the task. So why is my research important? Well, there are 3 reasons. The first one is to train our model to solve the specific task we want them to do. We need to use graphical processor units, aka GPUs. And GPUs consume a lot of energy. Plus, with the latest data set and the size of the models getting bigger and bigger, we need sometimes more than 1 GPUs to train our model. And training a model can take a day, a week, a month sometimes. So by reducing the size of the model during the training time, we lower the complexity of them, and we need less power to train them. So less power means less GPUs, so less energy. And the second reason is to close the gap with industry. Here in academia and in research lab, we usually 1 GPUs per person, and they are not the latest state of like the best GPUs, because GPUs are expensive and we can't afford like to have a farm of 10,000 GPUs. But companies like Google, Facebook, or Amazon, they have all those resources, which kind of creates a gap between what we do here in academia and what they do there in industry, because they have the computational power for that. So again, lowering the number of parameters in the model, reduce the computational complexity of the model, and we can compete a bit better with industry, which is still like a huge gap to close. Finally, the last point, and maybe the more research-oriented point, is I believe that by trying to reduce the number of parameters in a model, we need to understand which parameters are important for the model. And doing that during the training process of deep neural network really will help us to understand how do deep neural network learn. How do they learn? Do they need like all those parameters at the beginning of the training, and then as we go on with training them to solve the task, they just use less and less parameters? Or is it early in the process that they just like select a bunch of parameters that they want to use? And that will tell us a bit on how they learn, and with that we can learn how to better engineer them and better engineer the training of deep neural networks.